Okay, just to go over this last or first series lab that you should have done, just look at voltages really quick. If I put this across the battery, black on, did it backwards, red on the positive, black on the negative, I get 9 volts. Let's look at through the resistors. If I do this first resistor, I get negative 1.5. If I do it through the second one, I get negative 3 here. Let's do it through this third one. You always have to remember to put these in the correct order. The red had to go where the electrons were entering, and the black where they're exiting, the positive and negative side. And I get negative 4.5. Let's try to remember those numbers. 9, negative 1.5, negative 3, negative 4.5. And through a wire, 0. Now the currents, I have 0.3 amps leaving this battery. If I move this through the first resistor or after it, I get 0.3. 0.3 right here, and 0.3 right there, and even through any wire I get 0.3. So let's look at the lab that you had and check over some of your answers here. So what you should have noticed is that your data table should have looked like this. These should have all been negatives if you put the leads in the right direction. I understand that it's easy to make mistakes there. The battery and a wire had 0 volts. The current, all 0.3. What you should have seen is that the sum of the voltages across the resistors was 9 volts, or negative 9 actually, and the across the battery was 9. So the relationship there is that the battery basically gives you energy. Voltage is the energy per charge, and so you get your energy from this battery. And where does it go? Well, it's lost through these resistors, which turns it into heat. So they equal each other, just opposite. Question number 3. The currents should have all been the same, and the equation should have been V is I times R. And number 5, the answer should have been 8 volts just by multiplying. But the main idea we wanted to get across from this lab is that currents stay the same in a series circuit. They don't split up or anything. And that the energy here, how does that work? The battery gives it, and it's lost through these resistors. Hopefully that helps you understand current a little bit better and onto the parallel circuit. I'm going to have my parallel circuit set up, so if I put the voltmeter here, I get 9 across the battery, but let's see about the voltages across each resistor. The 5 ohm gives me about negative 8.996, really close to 9. This one, the same thing. And this one, 8.995, again, really close to about 9. If I put it across the wire like AB right here, I get negative 0.001. So a little voltage or energy is lost through that wire, maybe because of heat. If electrons are moving pretty quickly through there, there could be a lot of heat energy from that. Let's look at currents. So here I have 3.3 amps. If you remember, the series circuit had these same 3 resistors with the same battery, and it only gave you 0.3 amps. So this is giving us about 10 times the current here. What about I'm getting 1.8 amps, this one 0.9, and this one 0.6. This was the 5, 10, and 15 ohm resistors. If I look at the currents here, like this is 3.3, but when I get over here, it's 1.5, finally 0.6. I mean, think about how that current works. You have 3.3 leaving this battery, but some of them go through this wire, 1.8 amps worth. And so then you have, what do you have left? You have 1.5 to continue moving this way. It's going to go up this wire, and there's 0.9 that go up there. So 1.5 and 0.9 go through here. That leaves 0.6 left. This 0.6 is going to continue moving through this last resistor, up this wire, and then it rejoins with this one. So here's 0.9 and 0.6. Add those together and you get 1.5. And then you have that 1.5 being combined with this 1.8. And you're back to your original current of 3.3. Let's look at how that looks in our data table. Here's the voltages here, the battery, wire. Sometimes there is a little bit lost maybe how the currents work. So to think about those questions here, um, question one, you should have thought there's three different paths for these electrons. Number two, each electron only gets to choose one of those resistors to go through. Number three, the negatives across the resistors, um, those should have been negative numbers, and positive across the battery, because again, the resistors take away energy, or it's changed into heat, and the battery gives you energy. Where does it lose most of its energy? Through the resistors. The wire, maybe the 0.001 at times. The parallel circuit, how does the potential difference compare with the power supply? They're all basically the same. When you had negative 8.996, that's really close to 9. So it's basically losing the energy through each resistor. The current through one resistor is going to be less than the battery, but if you added them together for question 7, if you added them together correctly, the sum of the currents through those resistors should equal the current starting from the battery. And where does most of the current go through? It's going to be the least resistance resistor because it's easier to go through. The more difficult one would be the one with the most resistance. So that's going to have the least current. And you should have noticed that the current changes going through that wire because some of the electrons were able to flow through that other resistor. Let me just click back on here again. Just thinking about the main thing you want to know about this lab is that here's this energy the battery gives you. No matter what, each individual electron just gets to pick one resistor to go through. And where does it lose its energy? Through that resistor. So even though we only start out with 9 volts, each resistor loses about 9 volts worth of energy per charge. So it's kind of the opposite of a series circuit. In a series circuit, all the currents were equal, but in a parallel circuit, basically the voltages across the resistors equal the battery. And if you remember series circuit, all the voltages added up to be the battery, but in here, all the currents add up to be what the battery supplied. So the currents are changing, but they all add up to be what you had at the beginning. So that's the most important thing to know about these two labs here.